Hi kids, back with another, I don't even know what this is. Okay, I'm just up here, we're gonna do a lab, it's gonna be cool. So here's what we've got. So in yonder test tube, this pink solution is cobalt, hexa, aqua, and this is a complex ion, and basically the reason, and complex ions are known for having like a distinctive color. So this is cobalt, and it has a charge of 2+, but it also has 6 water molecules attached to it. And so that's where the hexa aqua comes from. It means 6 water molecules. So this whole thing has a charge of 2+. So what we're going to do is we're going to add some chloride ions to it. And that's going to come from concentrated hydrochloric acid. So what should happen, theoretically, is that should shift this reaction over here to the right. Now, when that happens, you're going to form cobalt tetrachloride, which means you're going to have 4 chloride ions attached to this. Now, if this happens, this has a blue color, so it's going to shift the absorption and emission of light from emitting light that makes it look pink to making light that makes it look blue. So we're going to shift the molecular structure. Now, the reason this thing has a charge of 2- is because the cobalt still has a charge of 2+. You're adding 4 chloride ions, which each have a charge of 4-, and that's how we end up at -2, and then we also get 6 water molecules kicked up. So, the other thing that we can do is that we can make this an endothermic reaction, and we can add heat to it. So, there are 2 possible products and 2 possible reactants. And what we're going to do is we're going to put a double arrow to indicate this reaction can go back and forth depending upon how this thing shifts. So the first thing I'm going to do is that I've got some 12 molar hydrochloric acid, and I'm going to add that to the test tube. And as I add that, you'll see if I shift it far enough, that blue is starting to last a little bit longer. And maybe a little bit more just for good measure. So there we go. So what I did, notice it's very blue right now, is that I had this complex ion with water molecules. I added a bunch of chlorine to it from the hydrochloric acid, and then that shifted it over to this COCl4, which has a blue color to it. So adding this shifted it to the right. So now what I'm going to do next is I'm going to say, well, if I add a reactant and that shifts it to the right, then I'm going to add a product and see if I can shift it back over here. So now I'm going to begin to add, and hopefully I've got a big enough test tube here. So now I'm going to add some water, and you can see where that water has been mixed, okay? See that variant right there? So it's also showing a nice difference in densities. So I've got this shifted back over here to the CO H2O6 on the top, but then the bottom is still the COCl4, and that's why that's blue. So we'll add some more water to it. Come on. Might have to give it a stir. Don't do what I'm about to do. Okay? So, don't use the pipette as a stirring rod, but there we go. So, now, so by adding the water to it, I've shifted the reaction back to the pink side. Now, if it follows, then I should be able to take and add heat to it, and then, because that's a reactant, and that should warm it up and shift it back over there. So I'm going to put that in the hot water bath, and that's going to begin to hopefully heat up. And as you can see, as that's heating up, you're starting to see some blue in there. So that's starting to get a nice blue color to it as that thing is heating up. Now I'm actually going to pour a little bit of that out so we can get all of that underneath there. Okay? So I've added that heat, and now that's done a nice job of showing, oh, if I add heat, I'm going to shift that over here to the product side, which is going to be blue. Now, the next question is, well, what if you remove heat? Well, I happen to have an ice bath here. So I'm going to put that in the ice bath. And as that cools down, you'll notice that that's starting to turn a pinkish color. Okay? So by adding this one, okay, so we've added some ice, right? So that's removing the heat from the reactant side, and that's going to shift it over here. So just like if I added heat, it shifted it to the product side. So if I remove heat, it's going to shift it back to the reactant side, which is what happened to make this whole thing go pink. So if I want to shift it back over here, okay, well, let's go back to the hydrochloric acid idea. So I add a little bit of hydrochloric acid. And that shifts it over there to the blue. So now, the question is how can I remove some of these chloride ions? Oh, if you remember your solubility rules, silver nitrate with chloride ions forms an insoluble precipitate of AgCl. So hopefully, by adding some silver nitrate, I form a precipitate that reduces the number of chloride ions, and so we got this nice precipitate that formed, and that precipitate is now sinking down to the bottom, and through the miracle of what is science, the solution is turning pink up here because this up here has had those chloride ions removed, and we're shifting it back over here. So this is just a cool way to showing when you have a reaction that's reversible. It's known as Le Chatelier's principle. So when I stress the system, it's going to shift in one direction. So if I add any of the reactants, it shifts it over to the product side. If I add products, it shifts it over to the reactant side. So it's just a way of shifting this from one side to the other. So, there we go, kids. Kind of cool. We're done.